Good morning, everyone. Hope everyone slept well. This particular time slot is what we call the hangover slot, but luckily I don't have a hangover. I hope, how are you doing this morning? Good? Good? Okay, awesome. Welcome to my talk about database migrations. And before we kick off, I want to point a finger at somebody right there. This talk is his fault. So if at any point you think, dude, you're on to, you're talking out of your behind, then he's to blame, not me. Okay. Okay, let's get going. Hi, I'm Michiel. Good morning again. I'm a developer, trainer, speaker. I do a little bit of consulting. I work for a company called 4Scouts, and we do all sorts of things in the continuous delivery, event sourcing, legacy, renovation area. If at any point later today you want to talk to me about that, come see me and I'll give you my card. Okay, this talk is about database migrations. Who here runs a relational database in production? Cool, pretty much everybody. Who has never had to do a change to their schema? Okay, who doesn't understand what the schema is? Shut up. Because the title of this talk is Database Migrations Without Downtime, and it's really about schema migrations. And schema migrations are, well, pain in the ass, really. The schema is the structure of your database, right? The structure of your table, structure of your database as a whole. Defines what the columns look like, what sort of data goes in there, all sorts of constraints and keys and stuff like that. The problem with that is changes. It is a relational database. If you change your schema, you need to change, or probably need to change the data in there as well. So what we're going to talk about today is mostly SQL related. And when it comes to schema migrations, there usually is what we call the up and what we call the down. So when you migrate from one version to a new version of your schema, we go up. And if you were to roll back, you would go down. Now, for people that who you here uses doctrine migrations, okay, that's about half the audience. For the other half, a doctrine migration could look a little like this. It's essentially a PHP class which defines an up function and a down function. Once again, the up function is applied whenever you apply this new version. So in this case, we are to create a new table, an address table, and the down function would roll that right back, which in this case is simply dropping the table, right? Now, doctrine migrations then supplies a little command line application and some other stuff, and then you can apply your migration, and that could look like this. And that's pretty much all the data you're going to get. Doctrine migration stores the state or the version of your database in a table, and when it applies a new version and it successfully applies that change, it updates the version in that table, so you always know what state your database is in, hopefully. Now, the tool I use the most is called Flyway. Flyway does not do down. It only goes up. And the reason that they do that is that rollbacks, and I will come back to that in a little bit, are essentially impossible in the general sense. So they said rollbacks, we're not going to support that. The only way is forward. And Flyway is, well, Flyway is a Java application, but you don't write Java in Flyway. You just write SQL, simple SQL files, which are then applied, and there's a lot more information in your database versioning table. You see when it was done, by whom, what is applied, how long it took, all sorts of metadata that I find interesting and useful in some cases, which is why I tend to use Flyway more than other tools. Now, some migration tools use transactions. So they start a transaction run your schema migration, and when that all works, they commit the transaction. I mentioned flyway doesn't do down, it only goes up because of rollbacks. Rollbacks are a specific kind of problem when it comes to databases, right? The rollback is essentially, we have our database in state A, we go to state B, and that's not the state we want to be in, and we want to roll the entire database back to state A, which is something that's, well, hard, because if you look at destructive changes to a database, and what I consider destructive changes are long-lived locks. A long-lived lock is destructive because it blocks your database from any other changes. So it's destructive not necessarily to the data, but destructive to the rest of the world, which is trying to interact with the same data, with the same table. Renaming is obviously a destructive change. And deleting, which is, well, renaming is a sort of a subset of deleting, essentially. But deleting is definitely a destructive change. And implicit commits, who knows about implicit commits in MySQL, for example? I see a few hands. When you do an alter table in MySQL, in some cases, and in a few years back it would basically be in all cases, an alter table would cause an implicit commit of a transaction. So let's say you're in a transaction, and inside that transaction you do an alter table, so you change the structure of your table inside that transaction. The transaction would be committed immediately, which means that the transaction cannot be undone. It cannot be rolled back. Now, in newer versions of MySQL, this has been improved a little bit, but there are still alter table statements which cause an immediate and implicit commit. So that rules out transactions in some cases anyway. Sharding is a problem when it comes to rollbacks. Let's say you have 2 shards and you update shard by shard in terms of structure. Then rolling back, I wouldn't know what that would look like. Same goes for multiple databases. When you have multiple databases, multiple data sources that all need to change in terms of structure, and one of them were to fail, you would roll back the other ones. But what if one of the databases is a NoSQL database, which doesn't support transactions and doesn't support rollbacks? So in all these cases, to me, that means that rollbacks are basically out of the question. A rollback is something which essentially doesn't exist to me, especially in large databases, in databases where changes take a long time. Take the address table, for example. If I were to create an address table, the rolling back that change is easy. I simply drop the address table. But I also lose a shit ton of information, potentially, right? But if I were to rename a column and then roll that back, in the time between the rename and the rolling back, there may have been X amount of changes to the table, to the data. So if I were to roll that back, I then need some way of reapplying all those changes on the column which is now no longer renamed. And this is only the simple case. So in the general case, my view is that rollbacks don't exist. The only rollback that you have on a database is restoring a backup, which depending on your database size and the amount of writes you do to a database may not be feasible either. So far the good news. The second half of the title of this talk is without downtime. And what is downtime exactly? Well, who has never had downtime? I'm sure we all have, right? Let's take a simple application. We create a package of that application. We shut down our existing application. We run a migration. We deploy the new package, and we run the application again. This is how database migrations usually go, right? The database migration and the code to use it are deployed in the same deploy, essentially, are packed into the same commit usually, deployed together. We take the whole application offline to run our migration. And then once the migration is done, we boot the application again. And that's it. Problem is, the longer the migration takes, the longer you are down. And to me, downtime like that is avoidable, and we should. So I don't think downtime is something we want. How do we get to a point where we have no downtime? Well, the easy approach is don't do a migration. Or, as somebody said to me this morning, don't use a database. Then it's be stateless from in your entire application, and it's easy. Unfortunately, we have realistic constraints to work with, so we have to use a database. So how do we get rid of that downtime? Now, let's take zero downtime deployments. We have a load balancer. We have version 1 of our application behind that load balancer. Then we deploy version 2 of our application. And we switch the traffic over to version 2, and we remove version 1. Nobody notices. At least that's the idea. And there's no downtime. We switch from version 1 to version 2 seamlessly. However, when you insert database state into this little mix, it becomes a little bit more interesting, a little bit more complicated. We still have our load balancer. We still have app v1. But app v1 expects the database to be in v1 as well, right? And then we migrate the database to v2, and now app v1 is broken. But we are also deploying app v2, which expects v2. So there's a window in time where we have 2 versions of our application running, and they both have a different expectation on what the database should look like. This doesn't work, of course. Now, what then is required is that the old application should work with the new state of the database. So whatever we do to the database, it must be done in such a way that the old version of our application does not crash, is not hindered by it, does not see or do anything unexpected. So that means that we need to decouple, and we need to decouple the migration from the deployment. So instead of doing everything together, we need to do it in a few steps. And I want to tell you a little bit about an interesting pattern which we can apply here, which is called expand contract. Expand contract is, if you want to look it up later, go to Martin Fowler's site. There's one of his many articles. This dictates how expand contract, or parallel change as he calls it, works. Expand and contract is based on the notion of backwards compatibility. And backwards compatibility, again, is what we need in this instance, right? The old application needs to work with the new state of the database. Expand contract. Let's say we have a bunch of clients talking to an API. And for API, you can read database, or you can read class, or you can read pretty much anything that client code were to interface with. We have an existing API, and we don't want to break that. So we enter what is called the expand phase, and we add a new API. We don't break existing things. We only add. And then we start deprecating the old API. And we say, okay, every client, every piece of code that interfaces with that old API needs to switch to the new API, one by one, until nobody talks to the existing API anymore. At which point we enter the contract phase. So we have now added all this stuff, and now we can clean up old things, and we can remove the old API because it's unused anymore. This is completely seamless and backwards compatible. And now we have contracted to the point where all the additional code, additional things are gone, and we're clean again. When it comes to databases, it means that we need to do non-destructive changes at all times. And non-destructive changes are additions, adding tables. That's a non-destructive change. Adding a column is generally a non-destructive change. Creating indices, usually a non-destructive change, depending on the database technology you're working with. It also means that if we do it like that, bless you, by the way, that we can always go one diff back in history. That we can always put our application in the previous state. And it can still work with the database as it is. Now, let's take a little example. Renaming a column. Renaming a column, that's a simple migration, you would say. But renaming a column breaks the contract that our existing application, which is running, has with the database. So we need to figure out, we need to split that so that the old application that's still running in production doesn't crash because the column is suddenly gone. The first step is we create a column with the new name. So we don't rename, we add. We always add. And then we start writing to both the old and the new columns. So any write that occurs that previously were to write to the old column, it's also going to write to the new column. So we're going to duplicate that data. And then in the third step, we migrate anything that is left behind, that we didn't touch. And then the fourth step, we read from the new column, at which point the old column is no longer used, and we can enter the contract phase. So the first part starts the expand phase, and then we're in the contract phase, and we can remove the old column and the associated code. So far, so good, right? Now, for those of you that were in my talk yesterday about continuous deployment and stuff like that, I mentioned a thing called feature toggle. And the feature toggle can be applied in this scenario, in this context of a database migration as well. Feature toggle allows you to enable and disable certain features and certain code paths in your system at will and at runtime. Now, when you translate that to a website, it's simply we go from one version of the website to the other based on a toggle. But if you were to translate that to the database, writing to the old and the new column and reading from the new column, we can put that behind the feature toggle. We can already develop that code, and then at some point when we're ready, switch on the feature toggle, and hey presto, now we're writing to the new column, and we're reading from the new column. So feature toggles can be applied here as well. Okay, a little sidetrack into NoSQL. Who uses any sort of NoSQL database in production? Okay. And is that Couch? Mongo? Anything else? Redis? Cassandra? Okay. Well, the funny thing, or the nice thing, well, Cassandra is an exception. But the nice thing about NoSQL databases is that they don't have a schema. So essentially, we're okay there, right? Well, what we can do with NoSQL is, of course, you still have your documents, you have your records, you have whatever it's called in that particular technology that doesn't have, let's say, the new column or the new field, if you will, or it still has the field with the typo. Now, what we can do are a few things. We can migrate during reads. So any read that we do, we change in line before we pass it on to the application layer. We change the data we get from the NoSQL database and essentially fix the typo. And then in the background, we can actually migrate all the records in the database itself. And at some point, we've migrated everything. That means that we never have downtime when it comes to NoSQL, which is a good thing. It does mean that you need a little bit more administration to figure out where you are in the process, how many records you still need to touch, what the latest update was, and things like that. Okay, then a little bit about large data sets. And with large, I'm not going to put a number on that because large is very much specific to your use case. But you could think of gigabytes or terabytes of database data. And what you can encounter with a large data set is that a migration takes a serious amount of time. Adding a column to a table which has X million records could take a while, depending on the database technology and the storage layer. So that's something to keep in mind. Another thing to keep in mind is long-running queries that potentially block your table or that don't work because you are blocking the table during the migration. That's something you need to be aware of as well. Long-running queries. Memory usage, very important to keep track of during migrations, especially when you start doing background migrations on NoSQL table and you're not careful about your memory usage. That's something that you need to be very aware of. I'm not going to give you any specific implementation details here, but it's something that you need to be aware of with long-running migrations. And of course, a migration can fail. In a simple context, a migration can fail because you made an error in the SQL, of course. But in the context of a large data set, it can simply fail because of timeouts, or the database server went away, or we have network issues, or something else that's going on which is preventing us from completing that particular task. So we need some way of resuming or restarting the process of migrating that data. And we probably also want something to alert us to where we are, how we're doing, logging, progress reporting. Okay, I now want to touch upon two alternatives to doing migrations like I stipulated earlier. And one of those is using a queue. And that is something you see more often, is something like this. We have a UI at the top which talks to the backend through a queue. So instead of doing REST calls or something, or it may even do REST calls, but probably it will put some sort of message on a queue somewhere, be that Redis or Rabbit or Kinesis or whatever, puts a message on the queue, and the backend in turn processes those messages and does something with them, right? Changes the database or whatever. And then the UI queries the databases through a data layer and gets responses back. Now, the nice thing about using queues like this is that we can essentially switch off the backend. And we can even take a part of the database offline if we can get away with that. The only thing here to keep in mind is that a queue can then fill up, of course, if we spend an inordinate amount of time keeping the backend offline. Depending on how big your queue can grow, that's something that you should be aware of. But at least this is something that allows you to then decouple the backend from the front end, and then you can let the backend do its thing, maybe regenerate a database or something based on existing messages. Now, another pattern which I use a lot, but mostly in the context of event sourcing, but it can be applied here as well, is CQRS. CQRS stands for Command Query Responsibility Segregation, and that's a mouthful, especially at 10 a.m. But basically what it means is that we separate the write from the read. So not the write as in left-right, but writing. Writing to a database and reading from a database. Why would we separate those? Because for a read, for the query side, for the UI side, you probably want to have a different data model, which is written in such a way or constructed in such a way that your query is as fast as possible, right? That it doesn't use any joins, that it doesn't do any lookups to external services, that all the data is flat and easily searchable. It may even be in a different database technology than where your write side is. So you may be reading from Elasticsearch, but you're writing to MySQL or something else. So we separate reads from writes, and conceptually that would look like this. We still have our UI doing the querying through the data layer, which then talks to a few databases. But on the right-hand side, the UI, instead of pushing updates to a queue or directly through a REST API calls to the backend, it issues commands. And those commands are stored somewhere and could potentially turn into events or something else. They're stored, and the results of that is streamed to event handlers, and they do something with those events. So what this allows us to do is, let's say the UI says, add this address. Okay, address added. And then we can store that data in a whole myriad of ways. In multiple databases, multiple database technologies even. We can store the same address in MySQL and in Elasticsearch together. And when we pull that back into the migration context, it means that we can, Gesundheit, that we can regenerate our data, our database, based on what we have stored here. So instead of doing a migration, we create a completely new database table with the existing information, and then when it's done, we simply swap over in the data layer here. So we don't do migrations anymore, we do regeneration, rebuild. It's a very powerful concept. Okay. I want to close this off with one or two tools that are available to use. Flyway is the one I use the most. A simple app. Liquibase, Doctrine I mentioned. Fing can do this as well. And there are a few other tools. But essentially, the tool is, that's my message, the tool is not the thing that matters here. The tool is simply the implementation. The key is, and that's what's in the recap, multiple steps, multiple small steps. Instead of the migration and the code that uses the migration together, we do multiple small steps. So we decouple, and we don't do breaking changes. Okay. If you want to read about this a little bit more, there is the Refactoring Databases book or Bible, which has a lot of these patterns as well. Databaserefactoring.com is the accompanying website. And there's a little bit in the dev book by Barsoom on GitHub, which details a little bit of these flows as well. Okay. It looks like we do have a little bit of time for some questions. Running a little bit short here. Are there any questions? Yes, sir.
Well, one challenge, of course, when you're doing the add and then deprecate and remove is if the column in the example could be not nullable, for example, and then you would have a problem where you're in a transitional state where you have to temporarily allow it to be nullable in one or the other.
Yes. So yeah, so for everybody else, the challenge with adding a column that is not nullable, you would either have to have a sane default value or have it temporarily be nullable. Yeah, that's right. That is something to keep in mind.
Or anything with referential integrity like that.
Yeah. Any other questions? In the back right there. With Doctrine migrations, you mean, or?
Can you recommend it, or?
Well, like I said, the tool is not the thing here. Doctrine migrations works as well as Flyway would. It's simple SQL. If you use Doctrine for your as an ORM, then it would make sense to use Doctrine migrations as well because that ties in together. I personally, like I said, I use Flyway a lot, but it's really not about the tool. It's really about how you architect the changes, and what tool you use is then secondary. It's probably, if you're in that context of Doctrine anyway, then you have that configuration set up, and it would probably make sense to use Doctrine migrations. But there are more. Laravel has migrations, so if you use Laravel, then it probably makes sense to use that package there as well. There's Liquibase. There's a whole bunch of tools which pretty much do the same thing with different flavors. So all in all, I don't think the choice of the tool matters that much. Does that answer your question? Yeah. Okay, cool. Yes, sir.
Did you ever try Kona online schema change?
No, I have not.
You tried it, we used it in production, and it works also very well.
Okay.
It creates the second table, and it creates triggers on the first table, and every migration which you do on the first table will also be applied to the second table.
Yeah. Okay, and how does that work with the app? How would the app know to switch from table A to table B?
It doesn't.
Okay.
It doesn't need to know that the table is being switched.
Okay.
It's also with zero downtime.
Okay, well, there you go. That's another slide then for the next version of this talk.
The only requirement is that the table doesn't, it cannot have triggers on it.
Okay. Okay, and is the change, is that versioned? As in, can you store it somewhere and retrieve it?
You can keep your old table, so if you would like, you can not drop your original table.
No, I mean the migration itself. Is the migration something you click together in the UI, or is it something that you store somewhere and that is actually part of your repository?
No, it's a command line tool, so it isn't in my code or something.
Okay. Okay, because that would be, to me, because schema migrations and any database change, like any infrastructure essentially needs to be part of your repository, at least that's my personal belief.
thing is that our tests are way too big to be automatically done for when we are deploying.
Yeah, I'm not necessarily saying that. I'm saying that the change, so the structure of the data and then the change to that structure needs to be part of your versioning.
Yeah, we keep them the commands in a separate folder,
Okay.
and so that the whole changes are kept in the version.
Okay, interesting. Thank you for that. Any other questions or tools that I don't know about?
I can share a little trick I did for one of the projects.
Persona online schema change. Yeah, persona online schema change.
Okay, Jeroen, do you want to share something?
Yeah, a trick I did for some of the projects in the past. We had a MySQL master database, and for some projects we even already were running a master-master setup, with basically a failover IP address that we were using to write to and to read from.
Mm-hmm.
And when we're doing the migration, we would point the read IP address only to one master, then decouple the replication to the slave, to the second master, do the migration on the slave, wait until it's finished, and then basically switch the IP address.
Okay, and there's,
You could or immediately after do the migration on the other master, or you could wait, see if everything works. If it just doesn't work, basically switch versions back. Then the problem still is you have to migrate the data from the new database back to the old one, but at least you can do the switch almost immediately.
okay, did everybody hear and understand what Jeroen was saying? Okay, let me recap. So basically he said we had a master-master setup, MySQL, and when we did a migration, we essentially decoupled the synchronization between the masters, pointed or migrated one of the masters, and then pointed the app in terms of reads to the new master, and then migrated the other master and then resync again. Yeah, that is something that could work, but I think comes with a lot of
You need to do and know what you're
a lot of overhead in terms of administration and needing to know what you're doing. Plus, I think there's a window where you cannot do any writing. Am I correct?
No, because you can still keep writing. Only there might be there's the window that you might lose the data for a period of time. You need to.
Yeah. Wow.
The data that you're missing is the data.
Okay. So at least we don't have downtime, but we have no data either. I'm joking. Like I said, don't do migrations or don't use a database. Then you're golden.
Time used it for basically small changes, but that would
Yeah.
take a very long time to run.
Okay.
And this way you could.
Well, that could work if you don't have a lot of writing going on at that point. If you do have a lot of writing going on, then you may want to choose another solution. Okay, anything else in terms of questions or suggestions or comments? Yes?
I was wondering, have you ever changed the primary key in this way?
Where I use it.
I want to say yes, but I'm not going to say it worked out very well. But that probably was because we didn't think it through that time. But what you could do is create a new key as a secondary key and then transfer that at some point to a primary key. But you're probably in that case better off with just applying something like queuing or CQRS and regenerate the whole damn table.
Yeah, that's what I did.
Yeah. That's probably the path of least resistance in that case. Anything else? Okay. If you want to reach out to me, that's my Twitter handle. I'll publish the slides on there as well. And my email address, blog. And please leave some feedback on the talk. Join in. Helps us improve as speakers. Thank you so much for coming, and have a great day.